Good day, game changers. So for today, we will be discussing about the formal definition of derivatives. But before we proceed with that, let's first recall the slope of the tangent line. So the slope of the tangent line to the graph of y equals f of x at the point P with coordinates x sub 0 and y sub 0 is equal to the limit of y minus y sub 0 over x minus x sub 0 as x approaches x sub 0, or we could also rewrite that as the slope equal to the limit of f of x minus f of x sub 0 all over x minus x sub 0 as x approaches x sub 0. However, there are times when we are asked to find the slope of the tangent line to a certain function without being given a point. So what do we mean by that? We are just asked to find a certain equation or a certain function wherein if we are given a certain point, it will automatically give us the slope of the tangent line to that graph. And how do we find that? That is by getting the derivative of that certain function. So what exactly is derivative? Differentiation is the first of the two major ideas in calculus, the second being called integration or anti-differentiation because it's just the opposite of differentiation. Differentiation is a process of finding the derivative of a function. This implies that if I say differentiate a certain function, it only means that you are asked to find the derivative of that certain function. The derivative is a fancy calculus term for the steepness or the slope. It can also be interpreted as the instantaneous rate of change of f with respect to x. So although derivative sounds like a complicated process, it sounds like a complex idea, it is just simply a slope or a rate of change. But if we say it's a slope of what exactly? The derivative of a function at a given point is the slope of the tangent line at that certain point. So if you are not given a point, then what you will just get is not exactly a value, but instead a function that will give you the slope if you are given a certain point. So simply put, if you cannot draw a tangent line, there's no derivative. Because as we said earlier, the derivative is the slope of the tangent line. And if the slope is undefined, then the derivative will also fail to exist. So knowing this, there are actually three cases where the derivative does not exist. The first one is when the given point has any type of discontinuity, whether it's removable, infinite, or jump essential discontinuity. Continuity is a necessary condition for differentiability. It means that you can differentiate a certain function if it is continuous. The derivative does not exist also at a sharp turn or at a cusp on a function. So there is no tangent line at a sharp corner on a function. So we have here the corner at P, so at a certain point P. So at this certain point, there is no derivative. Also the same as when we have a graph here of a function and there's a cusp at point P, there's also no derivative at this certain point. And lastly, the derivative does not exist when the tangent line is vertical. The reason behind that is the slope of a vertical tangent line is undefined, which, as mentioned earlier, if the slope is undefined, then the derivative will not exist. So how do mathematicians formally define derivative? So the derivative of a function y equals f of x with respect to x at the point x equals x sub 0 is defined as f prime of x is equal to the limit of delta y over delta x as delta x approaches 0, or the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0, provided the limit exists. So this limit is called the instantaneous rate of change of y with respect to x at x equals x sub 0. So this equation is actually the formula that we will be using to find the derivative of functions. There are actually many different notations for derivative. So if y is equal to f of x, the derivative of f is commonly denoted by f prime of x, d sub x of f of x, d over dx of f of x, d over dx of y, dy over dx. So all of them, if you see them, those notations are only asking for the derivative of f of x or the derivative of y in terms of x. As confusion may arise with the symbol delta x, we may replace delta x with h and rewrite the formula as f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0. So we will be using this formula for us to find the derivative of certain functions. So please click the next video for the examples of finding derivatives of functions.